Thank you. I'm actually going to undo all the good Nathan just did, encouraging people to speak. So public speaking is awful. It is horrible. Like, you sit there, you dread, you figure out you have absolutely no idea what you want to talk about. Then you finally decide on the topic, and you struggle to prepare. You do your slides, you try to come up with the content. And then you have to come up here and talk in front of all the people who are looking there and judging you. Or at least that's what a little person in your head keeps on telling you. It's actually not too bad. It's pretty easy to get up here and talk to people for a couple of reasons, actually. The first reason, which is the main reason, you are actually smarter than you think. Or the audience is dumber than you think. I don't know which way you want to swing on it. You still have something to say, something to share. Like, the imposter syndrome is strong with a lot of people in this community, but it is not a stoppage at all. The second thing, which is probably even more important, is so the second thing is audience is generally pretty sympathetic. Nobody threw Rotten Tomatoes at me, which is, I guess, is a big win. But it's not an academic conference, right? There's no opposition in the audience. Audience is generally waiting for you to succeed. So there's almost nothing you can do on a stage that will be bad. Their audience will not forgive, right? And another thing is, which I hear more often than not, I got nothing to talk about. I can't talk about something for 5 minutes. Everybody got a story. That may be something you like, it may be something you hate, it may be something you worked on, it may be something you failed. Everybody got a story. I guarantee you, if after this we go to a happy hour, and everybody starts drinking, and everybody separates in different groups, and I go to any group, it pretty much say that Docker is the worst piece of shit technology ever created. I'm going to hear an hour worth of opinions on both sides of the argument. That is the story. So submit. Like, it's not that difficult. There are millions of conferences out there. CFPs are open pretty much every other day. So submit to different conferences. What can go wrong, right? You submit to conferences and you get rejected. But even the people who speak professional a lot of times, they get accepted 1 out of 5, 1 out of 10 submissions they do. So the only failure you can have is if you don't submit at all, right? Then you don't even get to talk. And there's a lot of different venues to do, right? You can do lightning talk like this, which is 5 minutes. Like, who here can rant about something for 5 minutes, really? I mean, there's full-blown talks that are ignites, which I highly don't recommend for the first-time speakers. But there's a lot of venues to do it. And once you get accepted, I mean, the preparation part, it's not too bad. I mean, it really is dependent on how you want to prepare it, depending on personality. Some people repeat it to almost automatic way to say your slides. Some people, like me, just come up with an outline and then wing it. Just go on stage and wing it. The one thing I would recommend is practice in front of somebody. When you practice in front of a mirror, it is not at all the same as sitting in front of blinding lights looking at the audience of 200 people. Talk to a coworker, pick up, I don't know, a local meetup or something, just do that. And there's a lot of tips of what to do, but main thing is don't be boring, right? I mean, I said that audience can forgive pretty much everything, that boring is the other half of pretty much. Honestly, when you do talks, go for entertainment. I mean, you don't have to do an interpretive dance, although we've done one on this exact stage a year ago. But be yourself, like tell your story like you would to a colleague outside in a hallway. Do not read. Please do not read your transcript. I'm a grown-ass man, I can read. If you write, you can write your notes, you can follow it, but don't come out and write. If you put that much effort into writing stuff, you can write a blog, post a blog, right? And everybody will read it, it'll be much better. Don't overwhelm people with information. I mean, people only take away a couple of points, so show them those couple of points. And actually, the same applies to individual slides. Don't put a wall of text, don't put a wall of codes. Nobody's going to read that. I can't read, I don't want to. Use imagery, use bullet points, use short sentences, use something to help you out. Just tell your story, right? Think about it as talking to a whole bunch of your friends in a hallway over beers. And that's pretty much it. Like, hopefully next search, more of you will come out and speak, and more of you will speak today. And there's the gong. Well done, well done. Thank you, sir.
So how many of you are local to the DC area? That's awesome. So Leon mentioned coming and speaking at meetups. In this area, and probably the city where you live, you can eat free pizza at least 5 nights a week if you find a meetup. So one of the meetups in this area that you might be interested in is DevOps DC. We meet every month on the second Tuesday of the month. So you can come out in October. Optoro is hosting us. It'll be a great time. We're going to talk about some security stuff. So yeah, you should do that. All right, enough awkward talking while I one-handedly set up another laptop. Let's see what we can do here. Fred, why don't you come on up? We've got statistics for dummies. Mm-hmm. You can take that.
Hello. Are there any statisticians in the house? Good.
You're on.
How do I There.
Yeah.
Okay, statistics for dummies, and the clock is ticking. So data. Without data, you're just another person with an opinion, and everyone's got them. Without math, your interpretation of the data is probably wrong. So with statistics, you want to apply the math to the data, and you want to apply it correctly. Let's take, everyone knows what an average is, arithmetic mean. Average equals the sum over the number of samples. But then there's also this data point called a median. Wow, that slide didn't come out well. That's basically the midpoint of a data set. If you look at this data set, 33 is the median. It's also called the 50th percentile, which you can do quantile notation for 0.5. 90th percentile, that's the value which 90% of the values are below it. So in this case, 90th percentile, Q 0.9 is 100. 100th percentile is the maximum value, Q of 1. This is a histogram. It's one of the 7 basic tools of quality. It plots the sample value on the x-axis versus the number of samples on the y-axis. Wow, those lines did not work well. That's supposed to be a bell curve, also known as a Gaussian distribution. You'll see this with, like, if you graph in a histogram height of the population versus number of individuals who are that high. So in a Gaussian distribution like this, the median equals the mode equals the average. We talk about standard deviation. I'm sure everyone's heard about that. That's where 68% of your values are within 1 sigma, 1 standard deviation. 95% are in 2 standard deviations, 99% in 3, and you've heard of 6 sigma, which is kind of a manufacturing quality metric. That's a lot of 9s. Here's how you calculate standard deviation. You calculate the sample average, mu, then sum the sample minus u, divide by the number of samples, and take the square root of that. So it's pretty easily to code up. And this is handy. This is a histogram also, but this is a non-normal distribution. It's bimodal. You've got a mode here on the left and a mode here on the right. This is a non-normal distribution also. This is called a skewed distribution. It's got 1 mode here on the left. So with something like this, here's the mode, here's the median. What's the standard deviation of this? It's a trick question. Standard deviation is only really good for distributions that are basically normal. Percentiles. I talked about percentiles a couple slides ago. If you have sample set A and the 95th percentile is 10, and you have sample set B, which is 95th percentile is 20, what is the 95th percentile for the sample set of A combined with B? It is not the average of the 95th percentile of A and the 95th percentile of B. You actually have to combine the raw data and then calculate the 95th percentile. This is a fairly common statistical mistake that I've seen a lot. So be wary of this. All right, let's talk about the null hypothesis. Anybody here see the double, Richard Gere and I think Topher Grace in 2012? They had to figure out who Cassius the assassin was. So they used this thing called the null hypothesis. They said, let's assume Stephen Hawking is Cassius. We'll formulate a null hypothesis and say Stephen Hawking is not Cassius. So what you want to do here is try to disprove the null hypothesis. They had a bunch of crime scene photos. Stephen Hawking was not in any of them. So they proved the null hypothesis. Stephen Hawking is not Cassius the assassin. Richard Gere, the other main character, they say Topher Grace was trying to figure out if he was the assassin. So he said, okay, Richard Gere is Cassius. My null hypothesis is Richard Gere is not Cassius. Richard Gere was in all of the crime scene photos. Null hypothesis disproved. Richard Gere is Cassius. And there's And there's this thing called a p-value, which you can use to actually do this with real statistics. So don't be a dummy. Go learn some statistics. Thank you.
Well done. All right, David. Where is David? Do we have David? Who's next on my list there? Sharon. All right. We have to switch computers again. Computering is hard. Say something interesting while I get your slides. Your timer doesn't start until you get your slides. Here.
My timer doesn't start.
Yeah, it doesn't start yet because you have no slides.
So, hello everybody. Woo. So let's see if you can guess from where I am by my accent or by my name, because I'm not from here. You have less than 5 minutes, by the way. Nope. Nope. I wish. I'm from Israel, so really great being here.
Good.
Thank you.
Take it away.
Okay, so I want to talk about debug and control in the cloud. I'm from Encapsula in Perva. What we do is we develop a WAF and CDN as a cloud services. One of our biggest challenges maintaining our production environment is to know what's happening inside our servers in real time, or to fetch specific state information when we debug like a customer issue. We're looking for information like stuff like metrics, total request per second, total open connection, like other stuff like internal state of our modules, our memo allocator, our thread pools, or even as very specific information like the status of a cached resource under a site which is on our service. Usually, this information is a complex data structure in our code, and we were looking at a fast and easy way to get them, especially in the middle of the night. Badly, traditional logging didn't provide us a good solution. Logs used to store historical sequence of events. They are not suitable, not designed for fetching real-time state information. It's hard to represent complex data structures in regular logs. Sometimes looking for something in your log is like looking for a needle in a haystack. By the way, that's me still looking. So we wonder if there is a better approach. And then we came with the idea to generate the information we need on demand via a file system-like interface. Actually, it's quite similar to proc. For those of you who doesn't know proc, proc is a file system on Linux. It provides real-time information on running processes. Under the proc directory, you have a file for each process. When you try to print this file, you get live information on this process. The print command translates to a kernel code that prints the kernel data structure of this process. So we came with an idea to make a proc of our own. It's called a mini proc. It's based on a Fuse, which is an open source file system. It has a kernel module and a user space module with which your code integrates. You define a Fuse mount point, and then all the I/O operation done under this mount point are translated to a callback function in your code. And then in your code, you can generate the information you want. So now that you got it, let's see a small example and see how easy it is to integrate with it. Okay, so here you can see, let's say I have an application called MyApp on a server on the cloud, and I want to gather some information from it. So what I need to do, I need to implement two callback functions for which I gave a pointer. They are MyApp read callback and MyApp write callback. Those callbacks I use to process I/O events. Then I have a dedicated thread in my application to handle all this Fuse stuff. In my dedicated thread, what I do is to first create a mount point / MyApp folder on the hard drive, and then create files by the information that interests me. For example, statistics, thread pool state, and then I call Fuse loop function. Fuse loop function runs event processing loop that translates kernel I/O events into the callback I've provided in my code. So as you can see in the right screen, I'm logging into my server, browsing to the MyApp directory, and listing on the files there. I can see the statistics file. When I print the statistics file, I can see the statistics of my application. Printing the statistics file translates back to my code to the MyApp read callback, and then I can generate in real time the statistics of my application. As you can see, further calls to the stats file. You can see the current statistics. So this is mainly it's very easy to use, very easy to integrate. Other things you can do with it is, for example, implement like write handler that will allow you to change your behavior of application in real time. And you can alter the input with regular command line tools like grep and ls and head, etc., etc. This is mostly it. Thank you very much. If you have further questions.
Well done. All right. I have cajoled someone into coming up here unexpectedly.
This next awkward interstitial is brought to you by... So while Nathan gets the next slides up, I'm Josh. I do a bunch of stuff, but one of the things I do is apparently try to destroy IRC. Because, we're all on the Surge Slack now, right? Slack is awesome. Yeah, woo! All right, a bunch of you are in there. I founded a Slack for the DC Tech community. It's called the DC Tech Slack. You can get in there with dctechslack.com. It'll auto-invite. It's good stuff. I highly recommend it. We've got almost 2,000 people in there now. It's amazing. If you're not in the DC area, that's cool too. You can come and heckle DC. We have a cool community. Anyway, I just wanted to plug that real quick. dctechslack.com. Thanks.
What? Is this on? No, I'll have to use this. All right. Okay, so I'm doing mine Ignite style. So let's start the timer quite yet, and I'll explain what that means. It means I have exactly 20 slides, and my slides are going to auto-advance, fingers crossed, and I'll have 15 seconds on each slide, and that means that Nathan will just almost ring the gong, but not quite be able to. So I've set Acrobat Reader to auto-advance, but it's a little bit slow on the uptake on the first one, so we'll just get going here. Ta-da. And I walk away. All right, so my name's Clinton Wolf, and I'm the founder of an open source project called Ansible-DK. Goodbye, mouse cursor. And yeah, so it's an open source project. I am the DevOps practice lead at a company called OmniTI. You may be familiar with this. They're advanced, great. So I'm a configuration management specialist. So I especially work with things like Chef and Ansible, and especially the tools that sort of surround them. So I'm a huge advocate of making sure that you have an actual software engineering process around your infrastructure as code. So what is Ansible-DK? Well, Ansible-DK is a whole bunch of things glued together with a flamethrower and some hot rod wheels and a big Sharky thing on the front end. And it basically looks like that. And it's a great time to drive around and use it. But you may be thinking to yourself, if you're familiar with Ansible, why would I want that thing when Ansible is so simple? It's so easy to use. I don't need a flamethrower with a shark nose. But the reality is, if you've ever used any sort of infrastructure as code, that even though the tools you may be using may be simple, the consequences of using those tools are not. It's really hard to reason about what happens, and it's really hard to detect whether or not the changes that you're making are the actual changes that you intend to make. And so it's really easy to blow up production and do horrible things. So you need to be able to have a software engineering process which involves, on one side here, making temporary systems using infrastructure as a service providers, and on the other side, tools that will verify that what you meant to do is actually what you get. Unfortunately, all of these different tools are not included with Ansible, and even worse, they all have horrible interdependencies and are on two different platforms, Ruby, Python, and also Bash. So you would have to manage all of these things on your developer workstations. You don't want to manage all of this on your developer workstations. It's a complete mess. So we found that we were encountering this problem with our clients, and so we looked around for existing solutions that would help us here, and we found something called Omnibus. So Omnibus is a packaging system. It lets you take things like a captive Python runtime and a captive Ruby runtime, install them under opt-Ansible-DK, and then install all the other tools under opt-Ansible-DK and have them link against those so that all of those tools are in like a little jail. They never realize that there's anything outside of it, no matter what else is on your system. Then we package it all up as an operating system package, like an RPM, a Debian package, or a DMG for Mac. It's wonderful. And we didn't invent it. Chef did. Chef made Omnibus. That's how Chef is packaged. It's also how Chef-DK is packaged, and several other things are packaged this way as well. It's a really great tool. So I really have to emphasize here, Ansible-DK is a complete ripoff. It's a ripoff of Chef-DK, except it's missing an enormous number of features. But imitation is the sincerest form of flattery. Hi, Nathan. So anyway, the actual experience of using Ansible-DK, installing and upgrading it is super easy. It only installs under opt-Ansible-DK, so if you decide you hate it, you just blow it away and you're done. To install or upgrade it, it's just an operating system package. This is the Mac experience here, but it's similar under other OSs. To actually use it, you run an initialization command that sets a whole bunch of shell variables. This is just like how Chef-DK works. It's setting all of these things so that all the tools will now find the right packages in their little captive jail area. One of the main features of Ansible-DK is a generator. So this lets you generate playbooks, roles, and configuration files and other components of Ansible. It's currently in a pull request, is why it says vaporware, but anyway. This lets you customize your experience for your developers in exactly the way your site needs to. Another major feature is Test Kitchen integration right out of the box. Test Kitchen lets you create temporary VMs, converge against them, run tests, and then destroy it if it passed. That's fantastic. That is exactly what you need to do in order to find out whether the changes you made are good or not. It gets you in a cycle of editing, creating a temporary VM, converging, testing, and destroying, all in one neat little thing. I love Test Kitchen. Do you? You might not. You may hate Test Kitchen. That's fine. We've got other tools. There's Molecule. Ansible-DK does not dictate how you use it. There's a whole bunch of tools included. You could use none of the testing tools and only use the linters. That's fine. Now, you may also be thinking, hey, there's some tool here that's missing, like I use DigitalOcean, not AWS. Great. Let us know about it. Send a PR or just open an issue and say, hey, I wish I had DigitalOcean. We'll add it in. So finally, please, if you're interested, go ahead and download it. It's a great tool both for you and for an entire team. It's a great way to keep a team synced on Ansible. So download it at ansible-dk.org or even contribute.
Well done, well done. All right, next up we have Jake Vanderdray from Custom Ink. So Custom Ink made the t-shirts that we have here at SurgeConf. What do you think about that? It's pretty cool. I'm also pretty certain that Custom Ink is hiring, so if you're looking for work, you could do that. It's weird to find a job at a conference. It's not really weird for you necessarily if you go to a conference and get hired at a new place. It's weird for all the people you leave behind that want to go to that conference next year. right? Okay, before I hand the mic over to Jake, I want to just remind you that we have, after Jake, I'm going to give a lightning talk, but then we have open mic time. So if you have 5 minutes worth of something that you want to say, it looks like you do. Yeah, I'm going to put you right on the spot. So you're in the line. You're coming up. All right, Jake, take it away.
All right, thanks. Wow, there's actually a timer going. Okay, who am I? I'm Jake Vandre. I'm the manager of web operations for Custom Inc. Who's Custom Inc? We're the ones that printed the t-shirts, like Nathan said. You go online, you can design a shirt for your conference, your family reunion, your sporting event, and we'll print it, mail it to you, and then years later when you see somebody with that shirt, you'll be like, yeah, I was there too. That was awesome. That's what we do. Okay, so visualization motivates. What do I mean by that? Workers are 35% more productive when they're able to actually see their progress as they work through a task. I think that's amazing. There's a little caveat. I didn't completely make that up. I was in this Mind Gym motivation class where they talked about how to get the most out of a team. And they brought up the study. And I don't remember, is it 30%, 35, whatever. At any rate, the example they gave was if you had somebody who had to go through a task of filling out paperwork. The paperwork's in one desk drawer, they pull out a piece, they do the work, they put it in another drawer. Oh my God, that's terrible. But you do the same thing where you give them a stack of paper on top of the desk and they move from one stack to another stack. They suddenly become much more productive. So I've got an example where we did that. We had a problem several years ago where our servers weren't actually fully patched. That's probably never happened to anybody else here. I'm sure it's a really rare occurrence. But there's a couple of problems with patching. Sometimes when you apply them, especially when you've got like 200, they break stuff. They're tough to test. And they don't roll back well typically. And there's not a whole lot that's rewarding about applying them. You don't get hacked, that's great. So I created a dashboard, right? The dashboard shows how many patches you've got. We broke up the servers by group, assigned them to different people on the team. Then there's a couple other dashboards. How close are you to patched? Which servers do you not have patched? And then we did another thing, which was if you got your servers patched, you got money for it. Amazon gift certificate at the end of the month for anybody who had all their servers patched. I know, guys, we don't do that anymore. Why? Because this is doing it for us. Now, every Friday when we show up, we patch all our servers. Everybody gets it done. And part of it's because you get to watch it as you get to watch the graphs move as you patch them. And I just use basic tools, Chef, Graphite, Grafana. It's stuff we've got, works well. Nothing particularly fancy. And so that's it. Visualization generates motivation.
Hi, it's me again. Now I get 5 minutes with you, or you get 5 minutes with me. I'm not really sure how it works. We'll just let me think about it however I choose. So I think it's you get 5 minutes with me. So my name's Nathan Harvey. I work at a place called Chef. Maybe you've heard of it. We have this brand new open source project called Habitat. Maybe you haven't heard of it, or maybe you have. Maybe you got a t-shirt. You should come by and get a t-shirt if you haven't yet. But what is Habitat? First, Habitat is nothing like Chef. It's completely different in like every single way. But Habitat is this thing that allows you to build, deploy, and manage your applications. It's really about application automation, whereas Chef is about infrastructure automation. And just like everything else that's wonderful, Habitat starts with a plan. So the plan is how you define the application itself. We're actually going to take your application and we're going to package it up into what we call a Habitat artifact or a heart file. And we use low abstraction. So if you've used Chef before, what language do you use when you write Chef? Ruby, right, yeah. We don't use Ruby in Habitat at all. You write Bash when you write your plans, which is weird for us. But the reason we do that is we want to have the minimum abstraction required. We want to make it as easy as possible for people to get in and do this stuff. You capture your complete dependencies for your application. Everything that's required, you capture in this plan. You take this plan and you turn it into a package. The way you turn it into a package is you go into a clean room. You build it in what we call the Habitat Studio. So the reason you build it in a clean room is it's safe by default. There is nothing installed in this clean room. It's a little BusyBox application, so there's no dependencies there. If you can package up your application, all of your application, and get it to run in the studio, you can guarantee that it's going to run everywhere that Habitat will work. You take those artifacts that you've built, you put them into a depot somewhere. You might call that depot Willem. We call our local internal depot Willem, if you can see who's behind the screen there. It's a central location. It can be publicly hosted. You can have lightweight views. We run a depot. You can run your own private depot as well. You install these packages using the hab command. So there's a little command line interface that's there. You say hab install a package, and you can do good stuff with that. The packages end up on disk. If you've ever looked at the Nix operating system, and you look then at where Habitat installs its packages, you'll see that it is inspired by Nix. So you can have multiple versions of the same package running, and they all run cleanly without overriding each other or stepping on each other. Everything is there side by side. After you've created this package, you can post-process it. You can turn it into Docker container, and within that Docker container, you're going to have that package and the supervisor, which I'll talk about in a minute, that runs within that Docker container. So you can run it in Docker, you can run it in Rocket, you can run it in Mesos, run it wherever you like. And it works really well as long as you're talking about applications that run on 64-bit Linux with a modern-ish kernel, 2.6 or greater, but easily support proprietary software as well. So the supervisor then takes these artifacts and runs those artifacts. So the supervisor, there's a supervisor per artifact that you're running. It will install them automatically, keep them running, and it will help manage the configuration. So when you build this artifact that you're going to run wherever you want, the thing about it is the configuration needs to change. The application should be the same, but the configuration will change based on which environment it's in, what are the other actors within that system, and so forth. So the supervisor allows you to control or inject configuration parameters into that running system. You can do that through 12-factor stuff, like you could use environment variables, but you can also write out a file and then send that file off to those supervisors. The supervisors themselves form a ring, so they form this gossip ring so they can talk to one another. There's no central supervisor. We want every component of the system to be fully autonomous and acting together in concert to deliver the service that you're building. The supervisor supports topologies like leader-follower topology, an initializer pattern, or standalone pattern. They also support update strategies, so I can look after that depot where I pulled the package from, and if there's a new version of that, then I can decide how do I update this application. And then they also provide a REST API. So I can query that REST API to get the health status of my application. I can inject configuration parameters and so forth. So Habitat is application automation that travels with the application, and it works really well for existing and cloud-native software. And it's all open source and Apache licensed, and there's a whole lot more to do. So we invite you to play around with it, check it out, come ask us questions at the table, and get involved in our community. Excuse me. So join us on Slack, check out the site, habitat.sh, and that's it. My time is almost up, so I won't take any questions. But now I will ask other folks, who is ready to give a lightning talk? Heidi, why don't you come up first? Or next, I should say. Mike, did you move forward because you were convinced? All right, great. All right, so I've got at least 3 more victims, volunteers. Yay. All right, let's hear it for Heidi. Give her a big round of applause as she gets set up. Yeah. She took Leon's talk to heart. She's like, all right, now I'm going to do that public speaking thing. Yeah. So she's doing it tomorrow too. You might not have heard her. So this is a preview, maybe not of the same talk. Here you go.
All right. My name is Heidi Waterhouse. I'm a technical writer, and I'm here to talk to you about docs and DevOps and why you should actually do them and why it's not the same as user documentation, which is pretty awesome. Oh, they just started my timer now. Also, you should go back a Kickstarter called Guide to Responsible Communication. It's about not being a jerk when you write. That's my extra time. Why am I not advancing? Don't want to update. So, DevOps is a constant race against time. You're always running to be a little bit behind where you should be, and it's really embarrassing because you never get done what you know you ought to be doing. But that's okay. It turns out that nobody ever gets it all done, but what we need to remember is that people are storing critical information, mission-critical information, in their brain as if it was RAM, and when they get distracted, it all goes up in a puff of smoke. In IT, we talk about getting hit by a bus. This is our shorthand, a little grim, for maybe you lose a key member and you don't get to download them before they leave, or you have to walk somebody out, God forbid. So what are you going to do if someone gets hit by a bus? Well, you're going to hope you have some documentation from them, because otherwise you're just screwed. You don't know how they built anything. So you'd really like them to write things down, but that's not really how it ever works, because as we all know, nobody likes writing things. But if you're a figure skater, they make you skate in the opposite direction of the way you usually go to build up muscles. And I want you to think about making DevOps skate in the opposite direction of they usually go to build up some muscles for writing things down. They'll whine. I've done the 100 push-ups program. It was terrible. I whined the whole time, and I built up a lot of muscle that I didn't used to have. And then I blew out my wrist. So don't do that one. But it's going to build a lot of muscle that they didn't know they had, and that's going to be great. Because, newsflash, we work in corporate America, and none of us knows that our job is going to be there tomorrow. Like if, say, you work at Yahoo. I'm just saying, it's a bad day today. So you want to be sure that something's there. Now, as a technical writer, I care a lot about how documentation works. I want to control the horizontal and the vertical and the kerning. It's really important to me that it looks nice and it's usable and it's got white space and like font fondling is what we call this. But I don't give a fig what your DevOps documentation looks like. It doesn't matter. I really want someplace that is canonical that I can go look for things. That's all I need in life, just one place to look for things. And it turns out that if it's an ugly place, it's actually better. This is my favorite mock-up tool. It's called Balsamic, and it makes things look really sketchy when you mock them up instead of looking all polished and pretty, because people don't like touching things that look finished. But if it looks scratchy, they'll fix it. The next thing I want you to do is stop using SharePoint, like ever for any reason, but also look at your Confluence, and instead of having a whole bunch of silos where you store everything in different pages and wiki pages, I want you to put it on one big scroll that's searchable, because it turns out we have really great search engines and really terrible cross-document search engines. So screw the cross-document, just put it all in one document and scroll it down toward the bottom, and the further down something is, the less you should trust it. Now, lots of communication happens in Slack and other channels. And I'm like, how do you capture that and get it into documentation? Because that's really important, but nobody wants to take it out. That's tedious. So you use a special icon that doesn't get used for anything else to mark things. The key here is to put communication in the way of your DevOps so that it is harder to avoid documenting something than it is to go around documenting something. Like, laziness is your friend here. So how do you know if it worked? How do you know if you've gotten documentation correct? Well, you use the monkey test, right? You invoke the chaos monkey, which is just take somebody's pager away and send them on an actual vacation. And it turns out you're going to have an emergency. Something's going to go wrong, catch on fire, fall over, whatever happens, but at least it will be a controlled emergency. You know when they're coming back. Because it turns out if you practice emergencies, you get better at them. And if you don't practice them and Maria's in the hospital for obvious reasons and you haven't gotten the information out of her, you'll want to call her. And if you call anybody in labor in the hospital to get any DevOps information, I will come hunt you down myself, because that's not okay. So, in conclusion, Documentation for DevOps helps you not make a status page that looks like the flaming Hindenburg, because you can keep things up no matter what happens. And that's what we all really want, is to be completely invisible. Thank you.
Thank you. All right. So we have two more, but first we have to have a private consult. He's asking her right now, so how bad is it to speak for 5 minutes? And they also share something in common. They show up at conferences with extra slide decks on their computer just ready to present. Right, Mike? Yeah. Somewhere in there, yeah. You can figure it out, yes. All right, 6 spare slide decks. All right. We do have technology. It's coming. There we go. All right, now you can have the mic, and your timer's going to start.
All right, I'm Mike with the mic. I have had almost a full glass of wine. I realize that happy hour is about to start, so I'll be brief. This is not a prepared talk. This is not anything I wrote, but I am going to continue the bash and documentation love that Nathan and Heidi just showered us with. This is a blog post I came across from a thought worker a couple years ago named Pete Hodgson. He talked about this thing called a Go script. It has nothing to do with the Go programming language, but he actually had 2 blog posts worth of material to talk about this. And the idea is you start a new project, and it uses this language and this tool and this other thing, and it launches a service, and it's just kind of like this whole set of tools that you have to know off the bat, and it probably will take you a couple days, especially as a new developer, just to be productive. So what can you do? Wouldn't it be great if there was just a script that you just ran, said, go set up my environment, go build the code, go run the tests, go deploy to production. So I got kind of this idea stuck in my head at my last job, and I started trying to come up with a Go framework for Ruby. So I came up with the Ruby gem, and it was sort of like this, domain-specific language for writing this one file, And so I used that on a few projects, and it was cool. But then I recently had some time on my hands. So I was like, what if I did it in Bash? And not only if I did it in Bash, but what if I did it like I learned a bit about RBENV at this point. So I was like, wow, it's actually like a modular Bash program. So what did I do? I started fooling around, and let me blow this up. And I came up with this. Blow it up more. We can do that. Okay, so, I run Go by itself. It's like, oh, this is what you can do. Here are the commands you've defined. And if you, want to look at built-ins, you've got this whole array. Oh, look, there's all this fun stuff. And you can actually, if I want to know something about, well, I had the test command earlier. Let's look at that. Oh, look, I can find out more about tests. It's like this whole environment. Now, let's take a look at the script. That's the script. No, actually, that's so what we see here, let me blow it up a little more. It sources this Go core. That's like the core library. It also gives you access to the built-ins, and my scripts are in this little directory. And let's take a look at one. Oh, look, that documentation that I saw for that command, it comes from the header comment. I stole this idea straight from RBENV. And so the idea is you write not one monolithic script that goes undocumented and gets old and crufty in its own right, and you don't just shove shell commands in README and hope that they don't ever go stale. You actually have a script per thing. That script can get as gnarly and complicated as you want, but hey, documentation's easy. It's right there. And guess what? This is a test script. Did you know you could test Bash? Whoops. Let me use my tab completion. Well, nope, sorry, I said directory. Well, let me do that. Come on, yeah. Look, you can test Bash. So Sam Stevenson, the same guy who did RBENV, he wrote this framework called BATS, Bash Automated Testing System. And it's really great. Now, this is going to take a little while to run, so I won't wait till the end, but did you know it will actually run on Windows? I've got 5 different versions of Bash shell in Windows. It runs there. And of course, Linux. Come on, Ubuntu, you know me. We've been old friends. Why are you doing this in front of a live audience? You haven't been this slow before. Anyways, let me just, like I said, unplanned. I had it all loaded up and ready to go, and you know what? It works on Linux. I'll prove it to you, because guess what? You can run it on Travis. And what I was going to show you on Linux is that not only can you run the test, but there's actually a program called kcov that will collect coverage for Bash. And you can display it locally, but the best part is it will automatically ship it. You can't really see it until I blow it up. Screw it, I'll just go punchline. Coveralls. You can send your coverage results from Bash tests to coveralls. So like all this stuff I learned writing the script. So if you're interested and want to play around with it or talk about it, my repo is mblan go script bash. And I will also be speaking tomorrow, 11 o'clock, about trying to make the right thing the easy thing, which is part of what this is about. And thank you very much.
Thanks, Mike. All right, we have one more. Yeah, all right. So if you've been on the Slack channel, you already know Trevor, because you've been pretty active today on the Slack channel. Yeah, you have. Yeah. I'm going to turn it over to you. You have no slides? I have no slides. You're just going to no slides. You're a pro. All right.
No, I'm no pro. I haven't done any talking about this before, but I'm going to talk about something. Hi, I'm Trevor. Hi, guys, and gals, and everybody, inclusive. So I wanted to ask, how many people here are managers? Can you raise your hand? Awesome. How many people here have managers? Can you raise your hand? Oh, awesome. That's even more people. That's amazing. So I just became a manager relatively recently, and one of the things that I think a lot about is how to be a good manager. And what is a good manager? I don't know what a good manager is, but I've had some good managers and some bad managers. And what I keep thinking about, and when I ask people, because I ask a lot of people, what's a good manager, is that it all comes back to this concept of psychological safety. I know if you've been in one of these talks, someone mentioned psychological safety earlier from a Google paper, and you should check that out. That's awesome. But I was thinking, what in the world is psychological safety? What does that even mean, right? I think what that is, and I could be wrong, but if I have a group that report to me, or I'm reporting to someone, and they feel safe being vulnerable, that you can be more open and honest with each other. And that sounds sort of obvious, but I don't think it is very obvious, because not very many people do it, right? You know, especially when life is really stressful, you can sort of forget about that. A lot of the times when you're managing or thinking about managing, you get shoved into a role. You used to be an engineer, you used to be an ops person, and you're so good at that, you now have, they'd say, oh, you're so good at your job, how about you manage people? And oh no, that's not good, right? Because I'm not good at managing people. I was really good at being an engineer. Management is like this whole other weird discipline that has to deal with people. And you know, it's easy to fall into that trap of just do the work, or I want to be just another engineer, or I want to be just another ops person. But I don't think that's really where we want to go. Taking a step back, my job as a manager, anyone's job as a manager, is this, like, how can I build this place that's safe? So if you're managing people, I don't know. Try to like expose your vulnerabilities to other people. Try to make mistakes, or make mistakes. You don't have to try. Everyone does it. It's easy. And I don't know. Just get out there. It's one of those things I really, really care about. I think that we focus way too much on the technology of what we do, and not enough about the people. Because at the end of the day, it's all about the people. Everything we do here is to help people. Like, what does your business do? It generates money by doing something, and that something is probably beneficial for somebody, right? It all comes back to people. If you can, take your little group and make it a safe place, make it a fun place to be, then you're doing so much more benefit than just that technological problem that is hard to solve. Because without that psychological safety, you can't get to that higher level thinking. There's this pyramid, if you haven't seen it, called Maslow's hierarchy of needs. It's all the things we need as human beings. It starts off with food and water and shelter, and it goes up to love and caring, and right there in the middle there's safety. I feel safe. That means I feel safe where I live. I feel safe that I'm not going to lose my job. I feel safe that things are okay. If you don't have that, if you're scared that you're going to lose your job, if you're scared that someone's going to yell at you, you can't do any of the stuff that's higher up. And that stuff that's higher up, that's at really creative, innovative, interesting thinking. So I really encourage you, if you're managing people or are managed by people or work with people or are a person, you should think about how can I build around me this network of psychological safety, this network of vulnerability and trust. So that's all I got. I just thought I'd share it, and I hope you think the same way. If you want to talk about that stuff, I'm around. So thank you.